we have been talking about in determining if our relations, the given relations, are functions, if they are represented as mappings, and if they're represented as set of ordered pairs. Do take note that both of them will come from the definition that all the elements of the domain or x's are used, and each x should only have one partner. That is the main reason why in the set of ordered pairs, what we do is to check if the x coordinate is different. Because if they are different, that means each of them will only have one partner. And in the set of ordered pairs, it is quite automatic that all the x's are used. But this time, what if our relations are equations? How do we check if they are functions? So, which of the following are equations of functions? We still have to remember that for it to be a function, we should stick to the definition that all x's are used and that each x will have one partner. However, in the equations, all x's are used is a little bit vague because we don't even know which of the x's are here. Nonetheless, if we can put any value of x here, then that would be perfectly fine. Now, so we will focus more on this one, that each x will have one partner if we're talking about equations. How will we have this one? Now, let's say for example, the first equation, y equals 2x plus 1. If I will put any number here, this should only be just one number. So for example, if let's say I make x equals 1, y will be equal to 2 times 1. 2 times 1 plus 1, that will be 2 plus 1, and that is 3. That means for this specific relation represented by this equation, the partner of 1 is 3 and 3 only. 1 will not have any other partner. So if I would have, now will I have any other x that my value of y would be 3? The answer here is no, because no matter what we do, you can try so many, but the value of y, for it to be 3, the only value of x there would be 1. So we can say that number 1 is an equation of a function. How about number 2? Y is equal to the square root of x plus 1. If I will put here x equals 1, then y would just be equal to the square root of 1 plus 1, which would be the square root of 2. And I'm also guessing if I put here x equals negative 1, y would be the square root of 1 plus negative 1, and y would be equal to the square root of 0, which is just actually 0. The square root of 2 is an irrational number, that's why we leave it at square root of 2. And if I continue just putting numbers here, I will just have the square as x equals negative 1, I will just have the same value, or just one value of y. That's why 2 is also a function. However, let's take a look at number 3. So far, we've been getting that if we just solve for equations, we will just get one value of y. Will we have here in number 3, will we have that equation? Let's say x equals 1/2. So if I will replace that there, I will have 1/2 squared plus y squared equals 1. Now, 1/2 squared is 1/4. So I can have 1/4 plus y squared equals 1. If I will place it here, I would have y squared equals 1 minus 1/4. And 1 minus 1/4 is 3/4. Now, y squared here. If I'm now going to get the square root, if we recall when we solve radical equations, this will just be y is equal to plus and minus the square root of 3/4, which is actually the square root of 3 over 2, if you check it in your calculators. Now, what does this mean? This means that y is square root of 3 over 2 and y is negative square root of 3 over 2, which means for x equals 1/2, it has two specific y's. However, x should only have one partner. So therefore, because of this, this makes number 3 not a function. Now, do we have to check each and every number? There is actually a way for us to easily determine if the equation is an equation of the function. Take a look at the exponent of the y's. Let's clear that out. So, if the exponent of our y is even, then that is not a function. Because if we're going to solve it, such as this one, let's say we have y squared equals x. If we're going to solve only for y, we will get y as positive and negative, meaning we have more than one value. So therefore, if the exponent of y is even, just like number 6 and number 3, they are not functions. However, if the exponent of y, there you go, of y is odd, then it is a function. Just like numbers 1, 2, 4, and 5. These are functions. So far, to know if a relation is a function, we base it on our definition that it should be all x's are used and each x has one partner. And this is what we use, which is most evident in mapping. We also do that in the set of ordered pairs, but we focus on the x coordinates so that they should be different. And for equations, we should look at the exponent of y. If it's even, that is not a function. But if it's odd, it is a function.